Sage Buchanan.
And I'm Sarah Regan.
And today we will be conducting the Skittle Experiment. We will be working with theoretical probability and experimental probability. First though, Sarah, what is probability?
Well, Sage, probability is the chance of something occurring, such as this giant coin has the chance of either going on heads or tails.
All right, with that said, let's begin with step number 1. The theoretical probability of the Skittle Experiment. Step 1, theoretical probability. What are we going to be using in this probability exercise, Sarah?
Well, Sage, we will be using Skittles.
Okay, and how many times will we be drawing from that bag of Skittles?
We will be drawing 100 times, the big 100.
Okay, and how many colors are in that bag of Skittles, Sarah?
Well, there are 5 colors. It is purple, red, green, yellow, orange.
And that is all. Okay. Thank you, Sarah. So, if we divide 100 evenly between the 5 colors, what is the theoretical probability of drawing each individual color?
20 out of 100, Sage, because 5 goes into 100 20 times. But wait, that can reduce.
Oh yes, it can, because 20 goes into 100 5 times. So, you can divide 20 by 20, and that will be 1. And you can divide 100 by 20, and that will be 5. So now the reduced theoretical probability for each one of the colors, because they are equal, will be 1/5. Thank you for letting me understand that, Sarah. Now we can move on to step 2 of the Skittle Experiment. Now it's time for experimental probability. Yes!
Step 2, experimental probability. Right now I'm going to draw 100 times and separate the Skittles by their own colors into these bowls, while Sage counts to make sure that I do not go over 100. Here we go. Green, yellow, purple.
Okay, and that should bring our total up to 100. And just in case, let's count. And 100. All right, and now it's time to finish step 2, experimental probability.
Continued step 2, experimental probability. So we've already figured out our tallies for the Skittle colors, and now it's time to put them into fractions. The fraction for red is 25 out of 100, purple is 16 out of 100, green is 16 out of 100, yellow is 22 out of 100, and orange is 21 out of 100. But these fractions can be simplified. Red can be simplified by 25, which is 1/4. Purple can be simplified by 4, which will be 4 over 25. Green can be simplified by the same, so it's 4 over 25. Yellow is simplified by 2, so 11/50ths. And orange cannot be simplified because there is no common number between 21 and 100. So that is the new experimental probability for continued step 2 of the Skittle Experiment.
The Skittle Experiment prediction. If you were to perform the experiment 1,000 times based on our current results, we believe that a red Skittle will be drawn 250 times. How did we get this, you ask? Well,
What we do is we start with our original results for the red Skittles, which was 25 out of 100. What we do is we're going to set up a proportion. So 25 100ths is equal to x over 1,000. But we can simplify 25 into 100. 25 into 25 is 1, and 25 into 100 is 4. So now that makes it a whole lot easier. What we're going to do is we're going to make 1/4 right here compared to x over 1,000. So 4 times x is 4x over 4. Mark that out. And 1,000 times 1 is 1,000 divided by 4. So we're going to come over here and do our division. 4 goes into 10 2 times, which is 8. Subtract 2, bring down your 0. 4 goes into 25 times, that's 20. Subtract, that's 0. Bring down your 0. And 4 doesn't go into 0, so don't forget to put your 0 up by the 5. So that means that x equals 250 Skittles that were drawn out of 1,000. And that is how we got our prediction.
Compound independent event for the Skittle experiment. Suppose I was to take one random Skittle out of this bag. Green. And then I was to put it back in with replacement and take out another one. Grape, which is purple. Based on our results, you asked me, Sarah, what will these two events, what is the probability of these two events happening with replacement? Well, let me show you. First we got green, and our older result told us that it was 16 over 100. And then we also got purple, which was also 16 out of 100, which equals, or if you simplify it, it equals to 4/25 and 4/25.
Because 4 goes into 16 4 times, and 4 goes into 100 25 times.
Now, to find out what the probability is, you always multiply it. So, it is 16 out of
625.
And that is the compound independent probability of these two results of happening. Now, next time you do this, make sure every single time to simplify as much as you can. Compound dependent event for the Skittle experiment.
Suppose that I was to randomly draw out a green Skittle, and I took it out without replacement. And then, let's say I got another, or I got an orange Skittle and I took it out without replacement. Now, based on our original results out of 100, what would the probability of me choosing these two Skittles without replacement? So, let's work out the equation. Our first color that we drew would be 16 out of 100. And since it was done without replacement, this orange Skittle will now be 21 out of 99. We can simplify 16 and 100, which would be 4 and 25. So 4 over 25 times 21 over 99 is 84 over, let's multiply this, 5 times 9 is 45, carry your 4, 5 times 9 is also 45, plus 4 is 49, 0, 2 times 9 is 18, carry the 1, 2 times 9 is 18, plus the 1 is 19. And you're going to add this, and it's going to be 5, 17, carry the 1, 14, carry the 1, and your number is going to be 2,475. So your new probability, the probability of me grabbing
these two Skittles without replacement is 84 over 2,475, which cannot be reduced any further.